Understood, ma? So even this braking is also useless for us. Understood?
Hmm.
Okay. So this one is actually helpful. This kind of braking. Okay.
Okay, sir.
Okay. Now, how do you know this braking is better? Okay. This you will some you will learn by practice, and there are little techniques. First, you learn by practice. Then I will tell you the techniques. Okay.
Okay, sir.
Okay. So if you learn by practice, then you will remember. So which functions to choose first? Which one you choose as U and which one you choose as DV? This one is very important. Okay, in integration by parts. Understood? So there are a lot of
Understood.
options, but this option is actually the best one. Okay. The simple trick here is you will choose this we call it as first function. This we call it as second function. Okay, ma?
Yes, sir. Got it.
Okay. Generally, what we do. So integration is actually the first function we are differentiating, right? See here, ultimately, see first function, there is a u, there is a v, right? There is a
Yes, sir.
u. So what we have to do? There is a u and there is a dv, right? Okay. So this first function u is there, no? In the right hand side, here you need du, right?
Hmm.
Okay. And when we are breaking it as dv, you need a v also, right? So that means
Yeah.
this second function somewhere you have to integrate, right?
Hmm.
Okay, if you integrate dv, then you will get v, right? First function
Yeah.
you have to differentiate to get du, right? So
Right,
here
sir.
v is
Yeah.
there. V is there. That means you know how should you integrate dv. Okay. So the trick here is you'll choose the first function so that it is differentiating is very easy of the first function. Okay, because du is here, right? Du is needed, right? So first function you have to differentiate. Okay. Second function you choose such a way that dv to v. That means integration of second function should be easy. Understood?
Yes, sir.
Understood, sir.
Okay. So first function differentiation should be easy. Second function integration should be easy. Okay. That
Hmm.
is broadly the trick. Okay. Okay. So in this case, second function, this one integrating is easy. This integrating is difficult. This is easy only,
Hmm.
but it is not fitting. Okay. You have to look at the combination, but generally broadly, second function, the case where integration is easy. Okay, ma?
Hmm.
Okay. So for example, in this case, ln x. Okay. Okay. In this case, there are no two functions. We have to artificially create one function. What is the function that we'll create? We'll create it like this. Okay. Okay.
Okay, sir.
Understood. Integral of then what is first function? First function is u. And dv is okay. What is dv? 1 dx. Right? dv is dx. So what is v? v equals
X.
x. Okay? v equals x. And what is du? du is 1 by x dx. Right?
Hmm.
Yes, sir.
Understood. du is 1 by x dx. Now try to finish this integration and tell me what exactly you are getting using this formula. Done, ma?
Sir, we are supposed to find integration of u dv. Yeah? If that's the case, then I'm done.
Integration of this function, basically, using this formula. Okay,
Yes,
you
sir.
know
I
u.
got the answer.
What is the answer?
Sir, I got x ln x minus x.
X ln minus x. Very good. Okay, understood
Yes, sir.
now? Shreyas, you also got, ma? Shreyas, you
Oh,
are.
sorry, sir. I was in mute. Yes, sir, I understood. Yeah, I was
Got
in mute.
it. Got it, this one?
Yes, sir.
Okay, very good. Now here, x power x square e power x. Okay? Okay, x square e power x. Okay, now you have to decide whether you take x square and e power x or e power x and x square, whichever way you choose. Okay? Here in this
Yes, sir.
case, he has taken first function as x square, second function as e power x dx. Okay? By the way, integral of
Okay,
e
sir.
power x, you know e power x only, right? Derivative of e power x is e
Hmm.
power x, integral should be same e power x, right?
Yes, sir.
Okay, now try this. Okay, so if you try this, if you try this, tell me whether you have reached this point or not.
Yes, sir.
Take the first function as x square, second function as e power x dx. Uh-huh.
Sir, which answer are we supposed to reach?
We need to get into integral of x square e raised to x dx equal to x square e raised to x minus 2 integral x e
I
x.
got the answer.
Yeah.
Got it, ma? Till
Yes,
this
sir.
point? Till this point?
Yeah.
Okay. Now see the thing. Here we are able to express this integral as something minus again this integral, right?
Right, sir.
Okay. This we are able to express as its child only, right?
Hmm.
So now
Yes,
we'll
sir.
take this to this side. Okay. Understood?
Hmm.
Understood, sir.
Okay. So sorry. This we are able to no. This is x square, this is x e power x, right? Okay.
Hmm.
Now what we will do, so this one, what has, can you see here? X square has become x. Okay.
Hmm.
One level
Yeah.
reduced. Okay. Now if you try the same method on this, you might probably get as up to e power x itself. Okay.
Okay, sir.
One more iteration of this. Just try using the same iteration. X square has become x. using the same iteration. Just for try to evaluate this integral.
Excuse me.
Got it, Emma?
No, sir.
X e power x.
Not yet, sir.
Oh, okay. Just try. You should get this one. Then you will just replace this with this. That's it.
No, sir, I didn't get it.
Got it, ma, this one?
Sir, I got it until the second last step. After that, it's a little bit confusing.
This one,
Yes, sir.
no?
Now I got it, sir.
You got it, no? Okay.
Yes, sir.
So what we have done, we have used the same trick. Just that
Yes, sir.
we are
We use the
using,
rule again, sir. That's it.
we have
Then
to
fine.
use the rule again. Okay?
Okay, sir,
Okay.
got it.
Now try this one. Here again, you have two options. You take either cos x as first or e power x as the first. Okay?
Yes, sir.
Okay. In this case, e power x we are taking as the first. Okay? Then we are getting
Hmm.
this in this form. Okay? E power x cos x has become e power x sin x. Okay? Now, if you
Hmm.
evaluate this again you are getting in e power x cos x. Okay?
Okay, sir.
Okay. So this and this we will take it together. We will send it. So original one, this one e power x minus integral of e power x sin x, right? Now integral
Hmm.
of e power x sin x, right? That we are replacing
Yeah.
with this. Understood?
Yeah.
Okay. We are evaluating this again and we are getting this one. Okay. This will send it to this side. So 2 into this thing should become this thing and this one should become this plus this by 2. Okay. Just see whether you are getting this or not. So again, cyclically we are doing. It's like a loop. Okay.
Sir, I'm not getting the answer.
Sir, same, sir.
Okay. See, e power x cos x, right? What is our first function? U, right?
Yeah.
Integral u d. What is our formula? Tell me what is our formula? uv minus integral
Integral
v
of v
du.
du.
V du, right? First function is what?
Right.
U power x. And second function is what? Cos x dx, right?
Right, sir.
And what is v? If this is dv, what is v? V is sin x, right? Till this part is here. That is fine, no? uv minus integral of what is v? Sin x e power x dx, right? Till this part it is clear, no?
Hmm.
Agree, Amma?
Yes, sir.
Agreed, sir.
Okay. Now, coming from here, now let's evaluate the same method, integral of e power x sin x dx. Okay? Again, this is u, this is dv. Okay? And if this is dv, what is v? V should be minus cos x, right?
Yeah.
Okay, so then this becomes u into minus cos x. That is uv minus integral of, again, minus cos x into what is du? E power x dx, right? Agreed?
Hmm.
Integral of e power x sin x is this, right? Which is nothing but minus
Hmm.
e power x cos x plus e power x cos x sin x, cos x dx, right?
Yeah.
Agreed? So, this part is clear now? So, now this one we can replace it here, right? E power x sin x minus e power x cos x plus integral of e power x cos x dx, right?
Yeah.
This integral equals to basically e power x sin x minus this thing, right? Which is nothing but e power x sin x plus e power x cos x minus again integral of e power x cos x dx, right?
Yes, sir.
Okay,
Yes, sir.
but this should be equals to our original integral, right? Okay, integral of e power x cos x dx we are able to express again within itself, within its form, right?
Yes, sir.
Agreed. What does that mean if you bring these two together? 2 times of integral of e power x cos x dx should be equal to e power x into sin x plus cos x, right? Agreed. So what becomes of
Yes, sir.
integral of e power x dx, e power x cos x dx? It is e power x of sin x plus cos x by 2. Understood? This 2 we can bring it here. Understood, ma?
Yes, sir.
And then put a constant of integration, right? So that is what we are getting. Understood?
Hmm.
Clear?
Yes, sir.
So the same thing we have done. Why we have done? We have realized after doing with sin x, so after doing with cos x, we got a sin x. Okay, nothing else changed, right? Cos x has become sin x. Then we went one more step, and again sin x became cos x. Right now we are gathering these two cos x, these two terms. Understood?
Yes, sir.
Okay. So now this is something called reduction formula. Okay. What is the reduction formula? So for example, you have to evaluate something like cos cube. Okay. You have to evaluate something like cos cube x or cos square x dx. Okay. You don't know what is the formula for this, right? But you know what is the
Mm.
formula for cos x dx, right?
Yeah.
Okay. If there is a way to convert this from to this, something basically something plus this, then you know what is the answer, right? Basically, you are reducing a
Yes, sir.
square to the power 1. Or say, for example, let's say, for example, you have something like integral of cos cube x dx or cos cube or sin cube. We don't know what exactly is this. If there is a way of reducing this one, if there is a way something plus integral of cos square, if there is a way, okay, then this will help because cos square you are able to reduce to cos x. Okay, that is the goal
Hmm.
here. The reduction formula, reduction means what? Whatever is the power, this we want to reduce. We want to express this as something plus some reduced power. Okay, so look at this. the goal is this equals to something plus some reduced power. Okay. Ultimately, if you have reached this n as 3, okay, then 3 minus 2, 1, we will be able to do, right? That is the goal
Hmm.
here. Reduction formula means a big integral, we want to reduce it to a smaller integral. Okay,
Yes, sir.
okay. Now here what we will do, there is cos power nx, right? We'll write it as cos power n minus 1 into cos x. Okay, like this. Okay. Now again, the first function we'll take it as this one, cos power n minus 1. Second function we'll take it as cos x dx. Understood?
Understood,
Then
sir.
what will happen to du? So what is our function? U integral u dv equals to uv minus integral of v du. Okay, we want to differentiate this, we want to integrate this, right? Okay, what will become of du? Du will become n minus 1 into cos power n minus 2 into minus sin x dx. Clear?
Clear, sir.
Okay, and what will become of v? V should be sin x plane, right?
Hmm.
Agreed. So then what will become our formula? U into V. That is this into sin x. Cos power n minus 1 into sin x. Minus integral of V. What is V? Sin x. Okay. Into this one. Okay. Please be careful. Integral of V du. What is V du? V is sin x. What is du? Du is n minus 1 cos power n minus 2 into x into minus sin x. So we'll bring this minus. Okay, into minus sin x.
Okay,
So this becomes sin square x. Okay. Sin x and sin x will
Okay, sir.
become sin square x. So because there is a minus, this minus will become plus because there is a minus here. Minus of this one, right? So that has become plus. So what has this become? N minus 1 into integral of sin square x. This is sin square x cos power n minus 2 dx. Agreed? Till this, what is this clear?
Hmm.
We are able to express cos power n as in this form. But this is also not straightforward, right? This
Hmm.
is also tricky. Here also we are not familiar of this integration, right? We are not familiar with this integration, right? Now we will
Hmm.
use some other technique. What we will do? We will write this sin square as 1 minus cos square. Okay? Agreed?
Yes, sir.
Okay. So this part, please be careful. This became n minus 1 into cos power n minus 2. That is this one, right? N minus 1 into minus of cos square into cos square n minus 2. This becomes cos power n again, right? This one. Understood?
Yes, sir.
Okay. Now this one and this one we can combine, right? N minus 1, if you take it to the left side, n minus 1 plus 1, right? Understood? This we are taking it to the left side, that becomes n into cos power n dx, right?
right, sir.
Okay, that became cos power n minus 1 x sin x plus n minus 1 into integral of cos power n minus 2 x dx. Okay, so what have we achieved? Integral of cos power nx. This n also we can bring it to the bottom. Integral of cos power nx, we are able to express this in some reduced form. Okay. How this will help? If this is 4, we will reduce it to 2. And in the next iteration, this 2 will reduce to 0. Right? If this is 5, in the first iteration, this will reduce to 3. In the second iteration, it will reduce to cos x, which is very easy.
Cosec.
Right
Hmm.
now?
Right, sir.
Understood. This is, so for example, cos cube x dx. This has become, if you directly apply the formula, 3 minus 1 cos square sin x by 3 plus 3 minus 1 by 3, 2 by 3, integral of 3 minus 2, which is cos x dx. This is so straightforward, right? If it is 5, it was
Yes.
7, it doesn't matter. Whichever it is, we'll be able to reduce this. Okay? So with this method, cos power, whichever x, we will be able to calculate. Understood?
Understood, sir.
Okay, okay. So just try this one. This is very, very important. I mean, reduction formula are very, very important. Same thing we can do for sine power nx also, tan power nx also, cot power nx also, all of this. Okay? This is the same idea. Okay. So now the trick here is we have to break this as cos power n minus 1 x into cos x, right? So
Right.
probably you can try breaking this as cos power n minus 2 x into cos square x also. right? Now, if you try this breaking, it might get little tricky. Okay, that is where your intuition is very important in integration, because there is no straightforward way here. It depends on more on intuition and your learning of the subject only. Whereas in differentiation, it is pretty straightforward, right?
Hmm.
Yes, sir.
Here, it is not straightforward. You should have an understanding that if I do this kind of breaking, probably I will reach here and I will be able to do this. So some bit of trial and error is also needed. Okay, but if you do a lot of problems, no, these things will become straightforward for you. Okay, ma.
Okay,
So
sir.
that's why integration is more of an art than compared with differentiation. Okay, just do this independently and see whether you are getting the same thing or not.
Hmm.
Spawn. Go through the spawn flow.
Sir, can you explain how we got sine square x instead of sin x? Sir, in the
There,
step
there
n
is a
minus 1 integration.
there is a sin
N
x and you
minus 1
got.
integration.
Okay, so integral of u dv minus v du. This is v, and du has got
Yeah.
another sin x. No,
Oh, yeah.
this sin x into this one, right? V du, right? This into this we have to do.
Yes, sir.
Okay, so and there is a minus. So this minus and that minus will get cancelled and will become plus.
Okay, sir. That's how you get this thing.
Yes, yes.
Sir, can you turn the page once?
This one.
Sir, why do we add n minus 1 integration cos raised to n dx x dx?
No, forget about adding. We are just taking this to the other side. Okay, we are just taking this to the other side. Instead of that, he is saying that we are adding this on both sides.
Okay,
Okay,
sir.
so this one is also cos per n, this is also cos per n, right? That's why.
Yeah. Sir, so we take n minus 1 also to the other side.
Yes, of course. So this one, integral of cos power n x dx equals to something minus n minus 1 into again integral of cos power n dx, right?
Yes, sir.
Yes, sir.
Okay, so basically I equals something minus n minus 1 into I. Let's say this I is this integral. What does this mean? If we bring it to the other side, 1 plus n minus 1 into I equals to whatever, this leftover thing, right?
Right.
Yes.
Okay, equals to whatever that. So that means this means I equals this leftover thing by n.
And yeah.
Understood? I equals this leftover thing, whatever is this. So now what we have got with this, we have reduced cos power n to something in terms of n minus 2, right?
Yeah.
Understood now? Okay, so this way you try to do this by parts integration. Next class I will tell you some interesting tricks. Okay. So for
Okay, sir.
Sure,
example,
sir.
this one, first function, second function, first function, second function, like this. Okay.
Yes, sir.
Here probably first function is one, second function is first function is this, second function is one. Okay.
Okay, sir.
So you have to do in such a
Okay.
way that first function is differentiation is easy, second function integration should be easy. So you can try, if you are not getting, try another combination. Okay.
Sure, sir.
Okay, if you are
Sure,
not
sir.
getting, try some combination, then you might get it. Otherwise, if you're still not getting, just look at the solution. Okay. All of
Okay,
this
sir.
Okay, sir.
integration by parts. Okay.
Okay, sir.
Okay. So in this case, there is some substitution also involved, apart from by parts. Okay.
Hmm.
Uh, I think you should be able to do this. Try till this problem
50.
50. Okay, ma?
Yes, sir.
Sure, sir.
Try
Okay, sir.
till 50. We'll meet again on Monday, no?
Monday, Monday.
Monday,
Yes, sir.
what time? 7:30, yeah?
Yes, sir. 7:30.
Yes, sir.
So you don't have any extra classes?
Sir, we
Sir, we
might,
have extra
not
classes.
sure. So
Okay, okay,
sometimes
okay.
we'll have some knowledge like that.
Or otherwise, we can push it little later also. Probably like 8:30 or so.
No, sir. 7:30 is perfect.
7:30 is
We have
fine,
that time
but
only
we have
during
2 hours
extra.
after coming back, sir. That's more than
Okay,
enough.
okay. 7:30 is fine, no then?
Yeah.
Yes, sir.
Okay, okay. Good. So meet at 7:30. Then try to finish this till 50. Okay, ma?
Yes,
Okay,
sir.
sir.
Okay then. Take care. Bye bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.